In the last video, we had a car driving into a new speed zone. And we asked, how far into that speed zone would it get if it's accelerating by this much? Well, let's change that problem up a little bit. Here I'm giving you an initial velocity, the same initial velocity, v naught equals 20, and I'm giving you the same final velocity, 45 meters per second. But what I'm giving you here is I'm saying, hey, we started at 0 and we're going to 150 meters. That's how far into this speed zone we get. What I want to know is, how long does it take? How long does that take for me to drive my sweet 1969 Chevelle into that speed zone? So let's list out our variables and see what we can get. So first off, my final displacement will be 150. My initial will be 0. My initial velocity is going to be 20. And my final will be 45. Let's put units on all these. Now I want to know, what's my time going to be? Well, which equation could I use? I've got this guy. I've got this guy. Okay, and then I've got this guy. But I know that I have a positive acceleration. I know I have a positive time, but I'm missing both of those variables. I'm unable to solve either of these equations. What can I do? Well, in math, we can do this thing called substitution. Let's say I'm going to go, all right. Why don't we just switch this problem up? I could go, hey, v minus v naught equals at. Yeah, let's take that one more step. Let's divide this by a. So v minus v naught divided by a equals t. And then I can say, hey, let's just take this whole thing. Let's plug it in everywhere that I see t. Everywhere that I see that. Now, that's a great idea. It's going to make a lot of math. And it's going to start to look like this. I'm just going to show you how this starts to look. If you really want to go through and do the math yourself and figure out how to simplify this, you can. But I'm just going to show you this first step, and then I'm going to show you the last step because I don't want to. So that's what this would look like when we substitute that in. And we can do a whole bunch of rearranging and simplification, and we end up with an equation that does not depend on time at all. We'll end up with this equation. V squared equals V naught squared plus 2a, and then I always write this as delta x. I say delta x because delta is always going to be final minus initial, which in this case would be final minus initial, x minus x naught, which is really what we have going on up here. This guy right here, we could really simplify this to delta x. So that's what I like to use here, is delta x. So this equation does not depend on time at all. And so if I look back at this problem, I have all of the variables I need to solve this guy. So I got v, I can put that in, 45 squared is going to equal 20 squared plus 2a delta x. Well, that's going to be 2 times a times delta x is just going to be 150. And so I can solve this. Let's simplify these. Let's take those squares and let's actually square them. It's going to be 2025 equals 400 plus 300a. Let's subtract that 400 from both sides. And I've got 1625 equals 300a, divide by 300, and I'll be given my a. And so my acceleration will be 5.42. Okay, so 5.42 meters per second squared. And then I can take this, I can plug this right back in to this equation right here. And so I'm going to have 45 minus 20 divided by 5.42. That's going to give me my time. I'm just going to plug that in. That'll give me a time of 4.61. So 4.61 seconds. And there we go. So that's our combined equation. We now have three equations that we can pick from whenever we're solving a problem. We've got x equals x naught, our displacement equation. We have our velocity equation, which is really our change in velocity. Notice this guy could also be rewritten as delta v equals at. This guy could be delta x equals great. And then our new equation, v squared equals v naught squared plus 2a delta x. There we go. So let's start practicing this. This should be pretty straightforward. You're going to use it anytime you have an equation that's missing both a and t. So let's give that a shot.